Hi, welcome to lesson 2.2 where we're going to talk about dividing fractions. And through this lesson you're going to be able to draw a model to explain fraction division, find reciprocals of numbers, divide fractions by fractions, and divide fractions by whole numbers, okay? We're actually going to start with some terms and deal with the reciprocal thing first. So, reciprocals or multiplicative inverses, two different terms mean the same thing. Two numbers whose product is 1. That means you multiply two numbers together, it equals 1. We often use the term reciprocal. I think it's a little easier to say and a little shorter than multiplicative inverse, but either word works. So what we see is we have a fraction, 2/3. If I multiply it by its reciprocal, 3/2, I get 6/6, which is 1. Or if we cross canceled, watch that. The 2's cancel the 1, the 3's cancel the 1's, and now we instead have 1/1, which is 1. So the way that works. And the word inverse means, you kind of see the word invert in there, right? Well, that just means to turn over. So we're taking a fraction and we're turning it over. Now, we have to make sure it's in a regular fraction form, just a numerator and a denominator. No improper or no mixed numbers. We have to have either proper or improper fractions. Put it that way. So if we're going to write the reciprocal of 7/8, it already has just a numerator and denominator. So all we have to do is flip it. And its reciprocal is 8/7. We come down here to 1 1/2 and we say, oops, that's not just a fraction. It's a mixed number. So we turn it into an improper fraction. 2 times 1 is 2 plus 1 is 3/2. Now we flip it. And we have 2/3. And then 9 is 9 written as a fraction? It's not. So let's write it as a fraction. So we make it 9/1 and then we flip it and here's its reciprocal or its multiplicative inverse. So they're not equal to each other. But these are the multiplicative inverses of those other numbers that were given. And this is what we're going to use to help us do our division. Okay, so now in order to do the actual division, a couple things we need to keep in mind. One, once again, we don't need common denominators. All right, we're going to take our mixed numbers and make them improper fractions if we have any. Otherwise, we just start the division process. Here's our new step. We multiply by the reciprocal of the second number. So we keep the first number, we change our division to multiplication, and then we multiply by that second number. But think about it. If you want to, let's say you wanted to figure out, I don't know, what was 100 divided by 2? You might know the answer, or you might say, I could say 100 divided by 2 is 50, or half of 100 is 50. I can multiply. Okay, multiply by the reciprocal. What's the reciprocal of 2? It's 1/2. So we're going to do, when we say this, we multiply by the reciprocal of the second number. We do what's called keep, change, flip. And it's fine to use this as long as you know mathematically what we're doing. We're multiplying by the reciprocal of the second number, multiplying by the inverse of the second number, okay? But a quicker, easier way to sometimes remember that is keep, change, flip. Keep first number, change division to multiplication, flip second number. Keep, change, flip. And then we go to our multiplication process. Multiply across and reduce, or cross cancel, multiply across, check for reducing. Now we're going to have to do some examples. Okay, so let's take a look at some division here. And we're going to do this in terms of models, and then we're also just going to do the straight division so you see how that works together with this. So our first question is 3/4 divided by 5/12. So really, it's saying how many 5/12 are there in 3/4? Or how many groups of 5/12 are there in 3/4? All right, so I made a thing, a measurement here. There's actually 12 little blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I want 3/4 of them. I could even kind of look at it and say, okay, here's a fourth. See, here's 1/4. Here's another fourth. I don't do those squiggles very well. Here's another fourth. That's 3/4, right? I've used up 1, 2, 3, 4, 5, 6, 7, 8, 9/12. Okay. Now let's say how many 5/12 are there in 3/4? Well, I'm looking from here to here. How many groups of 5/12 are there? Well, let's see. Here's 1, 2, 3, 4, 5. Here's 1 5/12. How many more do I have left to color? Well, I'm going to color it in a little bit different color. 1, 2, 3, 4. I ran out. So I have 4 out of 5. I have 4/5 of 5/12. Or in other words, I have 1 whole 5/12 and 4/5 of another. So 1 and 4/5. Now, let's see if we can't get a similar answer doing our division and that keep, change, flip idea, multiplying by the reciprocal. When I say multiplying by, that means first number stays the same and I multiply by the second number's reciprocal. So let's try that. 3/4 divided by 5/12. Okay, let's rewrite. Rewrite each step as you go. Keep the first, 3/4. Division becomes multiplication. Reciprocal of 5/12 is 12/5. Okay. All right, let's just multiply across on this one, just because we can. 12 times 3, or 3 times 12 is 36. 4 times 5 is 20. Let's reduce. 4 goes into both, so we have 9/5. How many groups of 5 are there in 9? That's right, there's 1. And how many are left over? 4. Look at that, 1 and 4/5. So we get the same answer, whether we do it visually or just do the straight division. This lets us see, okay, we have our group of 3/4. How many 5/12 are there? Well, there's 1 whole 1 and 4 out of the 5 parts left. So that's why it's 1 and 4/5. Okay, now let's take a look at this one. 1/2 divided by 1/8. Okay, so let me mark off half here. Half of this thing that's broken up into eighths is right here, isn't it? 1/2. How many 1/8 are there in 1/2? Well, let me see. Here's an eighth. Here's another eighth. There's another eighth. Gotta get some more colors. Here's an eighth. And here's an eighth. Just color that one in black. How many different 1/8 are there? Because that's the question. Well, I see 1, 2, 3, 4. Now, let's try that using just the regular division, that keep, change, flip idea. 1/2 divided by 1/8. Keep the first fraction. Division becomes multiplication, and we write the reciprocal, 8/1. All right. Should we cross cancel this time just because we can? 2 divided by 2 is 1. 8 divided by 2 is 4. So now I have 1/1 times 4/1, which equals 4/1 or 4, which is the answer we had up here. Okay, so let's take a look at a problem where we have to divide by a whole number. Okay, so like I said earlier, anytime you even have a mixed number, you need to write it as an improper fraction. Well, 6, a whole number is kind of like a mixed number, so let's write it as an improper fraction. So we have 2/3 divided by 6/1. Write this step down so you know exactly what you're dividing, so when we get to the next step of multiplying by the reciprocal, we keep the first fraction, division becomes multiplication, and we write the reciprocal, we know exactly what we're doing. Don't try to do too much at once, okay? Now we multiply. 2 times 1 is 2. 3 times 6 is 18. Oh, I can divide that both by 2 and get 1/9. So 2/3 divided by 6 is 1/9. So how many 6's are there in 2/3 basically is what we're asking? 1/9 of it, okay? 1/9 of a 6 is in 2/3. Okay, now let's take a look at an example where we can use some dividing fractions and such here. A rope is 8 meters long. How many 3/5 meter pieces can be cut from the rope? And then how much rope is left over? So if this is my rope, that's 8 meters long. They're asking, if I break it up into 3/5, little chunks, chunk, how many of these little 3/5 chunks are there? So is this 8 divided by 3/5 or 3/5 divided by 8? That's right, it's 8, because our whole is 8, and we're saying how many little 3/5 are there, right? 8 divided by 3/5, because it said how many 3/5 pieces are there in the 8? Okay, so let's write 8 as a fraction, because we know we should. Okay. And then we do, hold on. Okay, so we have 8 divided by 3/5, so now we do keep, change, flip, we multiply by the reciprocal of the second number. All right, can't cross cancel, so let's multiply across. 40/3. Okay, that doesn't mean much in measurements. So let's see here. We know 3 doesn't go into 40 evenly. So let's figure out how many times does 3 go into 40? I'm just going to do that up here. 3 goes into 40. Well, 3 goes into 4 once. You know, 3 times 1 is 3. That's 1, that's 0. 3 goes into 10 3 times. And we've got 1/3 left over. So there are 13 whole sections. So 13 sections of 3/5 meters. So that's the answer to the first question. You can cut 13 sections. Now the question is, how much rope is left? Well, if I have 13 sections that are 3/5 meters long, how much of the rope did I use? So what is 13 times 3/5? Well, now we're going back to stuff we did in a previous lesson. 13/1 times 3/5. Now I don't have to do the reciprocal because I'm already multiplying. 13 times 3 is 39. 1 times 5 is 5. Now, some of you are saying, oh, okay, well, if I have one more fifth, I get 40/5, which is the same as 8. And you know, okay, my answer is 1/5. If you don't, then you say, okay, well, now this is how much rope I've used. What's 40? Whoopsie, it's not 40. Not there yet. We can go up here. What's 8 minus 39/5? Well, we gotta have a common denominator, so I multiply by 5/5, that's 8/1. 40/5, there we go, minus 39/5 is 1/5 of a meter left over. So you use almost the whole entire rope. So now you've seen division of fractions using models. Using our method of multiplying by the reciprocal, we divide fractions by fractions and fractions by whole numbers and apply it a little bit to real life. Thanks for watching.